Next, we'll be looking at topic 3. We're still dealing with parallelograms, so we still are dealing with those properties we talked about in topic 2. So, in order to do problems dealing with algebra and numbers, we need to identify whether we are looking and working with an angle, a side, or a diagonal. And this comes from our properties, because our properties tell us that our opposite angles are congruent, our opposite sides are congruent, or our diagonals bisect each other. Now, once I know my answer to step 1, what am I dealing with, I'm going to determine which property I'm using. And once I know which property I'm using, I'm going to go ahead and apply that property to the problem. So let's scroll down and look at a few properties and how to use them algebraically and numerically. I'm going to start with example 1. I notice that 42 degrees gives me a hint that I'm probably looking for, what's this? It's an angle. So I'm looking for an angle. Now, which property deals with angles? My opposite angles are congruent. So how would I set this up? I would say that the question mark is equal to 42 degrees. Now the next one gets a little tricky. Example 2, I'm still looking for an angle. I have one property that deals with angles, and that is my opposite angles are congruent. So when I look at that, I know that if A up here is 120, then C has to be 120. Now the other thing I know is if D is a question mark, then B is a question mark. So I can use the fact that this is a quadrilateral and adds up to 360 degrees total and find out what that question mark is. So I have 2 question marks plus 120 plus 120 equals 360. So I'm going to use an X for my question mark just because I'm used to doing that in algebra. I get 2x plus 240 equals 360. I subtract 240 on both sides of the equation, and I end up with 2x is equal to 120. I divide by 2, and x is equal to 60. So how big are my question marks? 60. But what I do notice, which is kind of an interesting thing to notice, these two, they're on the same. They happen to add up to 180. Now that necessarily wouldn't tell me that something's a parallelogram, but it does help to know that my consecutive angles, the ones that are right next to each other, all add up to 180. So it's a byproduct of the fact that opposite angles are congruent. So let's go ahead down and look at example 3 and 4. So when I look at example 3, I notice that the 55 is kind of between the x and the y over here, so that's a side. So is the question mark. So I'm looking for a side. So what do I know? I know that my opposite sides are congruent. So if this is 55, the one across from it also has to be 55. So when I go to example 4, PR. Oh, well, let's look at PR for a second. PR is a diagonal. So I'm looking for PT, which is part of a diagonal. So when I look at PT, I'm going to go ahead and highlight that in red. It's just that little piece of it. So I'm looking for a diagonal. So the property I'm using is that my diagonals bisect each other. That means if from here all the way to here is 56, when I break up that 56 and I divide by 2, I get 28. So each little piece is 28. So from P to T is 28. I took half my diagonal. So go ahead and try a few problems.